My name is V. Nikhil. I'm studying in Institute of Aeronautical Engineering. My course name is Essential of Problem Solving. My topic name is Modeling the Locality in Graph Travels. Modeling the locality in graph travels. How many across locality in graph travels determines performance. We introduce a graph scientific locality called vertex distance. So different graph visualize how topology shapes behaviors and the theory to particle system and algorithm design. Why locality matters in graph travels. Graphs are the foundation for social networks, biological interaction maps, web inducting, and many scientific workloads. The runtime of graph algorithm depends many patterns with locality in poor misses, missing of memories, execute time, understanding and modeling locality lets us performance of making design of choose of algorithm and system. Why why traditional locality models fall short? Classic locality matrices were developed for locality of reference, the capture volume or behaviors, but miss how graph technology degree this distributions short paths and shapes the order of timing of node during travels. As a result, based models cannot actually forecast the graph algorithm. Introducing vertex distance, a new metric. Vertex distance, how many nodes across occurs between how visits to the same vertex during a traversal in locality specific to graph. Wow. Short vertex distance amplify good behavior while long distance indicate walk locality. Unlike frequency, vertex distance link travels order to enabling predictions of miss miss rates of vortex distance. Vortex distance in but first search BFS. BFS Programmism. BFS visits nodes by distance from the source. The ordering generates correct, corrected steams nodes in the same level and adjust levels tend to be across in the BFS. Locality implications. Vertex distance distributions of BFS allows to us establish the fall within capacity windows, misread without full simulations. Using vertex distance, we can logically related graph properties. Example, degree expansion to expect of BFS. Modeling locality, three predictive models. Model 1, random graph. Model 2, RMAT graph. Model 3, degree and edge distribution. Uniform edge probability provides closed from probabilized vertex distance distributions useful as for unstructured graphs. Extends the random model with parameters of catch for communities, structures, and heavy degrees of distribution typical of real-world graphs. A paramagnetic establisher using average degree, second order degree, mordant and edge locality to BFS level size and resulting issue of this distance for particle performance of degree distributions. Together, together this model theoretical graph format is empirical in the across of graph formidable. Visualizing locality difference. The gallery shows tracks random graphs produce boundary uniform distance RMAT and real world networks produce hotspots weather communities and connected short distance. This difference explains why identity can have different behavior depending on graphs. Particle impact on graph algorithms and systems. Understanding vertex distance enhance particles optimization locality ordering data lagouts CSR recording locality preservative index layouts and informed selection of push or pull stages or paragraph organisms parallel organisms. It also informs the memory system of reduce maximum data occurs. BFS locality in dynamic and online graphs models. Real application often operated by dynamic graphs user interaction streaming updates on networks online local and dynamic local models extends vertex distance in hand handle into a deletion of the provide a framework to reason about locality and design that maintain good behavior of graph evolves. Conclusion. Locality for scalable graph processing, vertex distance, third models, applications, a particle, matrix linking order of vertex distance use engineering and research as a predicting behavior of the both algorithm choose of systems and designing of graph processing directions integrating locality approaches into learning system GNS and runtime optimizes to close the loops between algorithms and hardwares of format to parametric matters using degree static of dynamic graph optimization. Thank you for your time and affection.